Hi, and welcome to an overview of the circulatory system. But first, let's talk about Amazon. Amazon? Yep, a big company with a lot of functions, but many of us see it as the most efficient shipping company on the planet. Think about Amazon Prime. You can order an item online, and just 2 days later it will arrive at your doorstep. In some places, you can even use Amazon same day to get items within hours. Amazon has optimized the concept of delivery, from where your package is stored to how it gets to you, what route it takes, what it's transported in, and how easy it is to return it if for some reason it doesn't meet your needs. Now, despite how impressive and efficient Amazon might seem, it's still nowhere near first place in the shipping category. That award goes to Mother Nature and the circulatory system.
Don't tell my heart, my aching, breaking heart. I just don't think you'd understand. And if you tell my heart, my aching, breaking heart, he might blow up and kill this man.
The circulatory system is a vast network of organs and vessels that is responsible for the flow of blood, oxygen, nutrients, hormones, and other gases to and from cells. To explain how the human body expertly keeps itself working, let's talk about the circulatory system in terms of Amazon-style shipping. Let's imagine that the heart of Amazon is an enormous warehouse that pumps out hundreds of thousands of packages into 18-wheelers and also receives those trucks again once they are empty and have dropped off the packages they were carrying. This is exactly how your circulatory system works. Nutrient-rich blood is pumped out of the heart with destinations all over the body. Once the packages, which are oxygen, nutrients, and hormones, have been delivered, the nutrient-depleted blood flow goes back to the heart. So you can remember it like this. Arteries, they're red. They're red because they're warmer, full of oxygen, and hemoglobin, which has a red color, and other nutrients. Veins are blue. They're blue because they're colder. They're empty of oxygen, hemoglobin, and other nutrients. So if you're ever looking at your arm and you're thinking, oh, blue versus red, veins are blue, arteries are red. Now this is a very simple overview, but you need the foundation so we can keep building on it. Now that we know the basics of how blood flow works, let's go one level deeper. There are two sections in the circulatory system: systemic circulation and pulmonary circulation. As you can probably guess, systemic circulation takes place in the whole system, aka throughout the entire body, except the pulmonary region, which is covered by pulmonary circulation. Pulmonary just means lungs, so pulmonary circulation refers to how blood flows to and from the lungs specifically. Systemic circulation refers to how blood flows to and from the rest of the human body system. So why do systemic and pulmonary circulation distinctions matter? Because, and this is important, the circulatory system is not just one big circle. It's more like a bow. One side with a big loop, which is systemic circulation, and one side with a small loop, which is pulmonary circulation. They're connected in the middle by the heart. The heart itself is about the size of a human fist and has 4 internal chambers. The upper ones are the left and right atrium, and the bottom ones are the left and right ventricle. Remember, right and left sides here are always relative to the human body who contains the heart. So your right ventricle is on the same side as your right hand. But if you're looking at a picture of a heart, it might seem like a reflection, and it might seem to be on the wrong side. So just remember to think, what side would that person's right hand be on? That's the same side as the right heart chambers. Now the heart is like a gas pedal, and blood needs a boost to pump it where it needs to go. So let's track some blood as it heads back to the heart. It's blue, it's cold, it's in a vein, remember, and has no oxygen or nutrients anymore. It enters the heart at the right atrium, gets pumped down into the right ventricle, and in that way it's gotten the speed to be pumped into the lungs, where it will pick up more oxygen, nutrients, and hormones. Once it leaves the lungs, the blood has become red, warm, and full of nutrients, but it has slowed down again. So the blood enters the heart once more, this time through the left atrium, then down to the left ventricle, and then it shoots out to go deliver its packages, aka the blood and other nutrients, to the rest of the body. So let's think about a real-life application. When you go to the doctor and your blood pressure is taken, it always appears like a fraction, right? With a bigger number on the top and a smaller number on the bottom. But how does that connect to the circulatory system? Well, the top number is called systolic, and it measures the highest pressure when your heart beats and pushes your blood around your body. The bottom number is called diastolic, and measures the lowest pressure when your heart relaxes between beats. You can remember which one is which because diastolic starts with a D for down, so it's always on the bottom level. As you can see in this graph, high blood pressure is what it's called when you have a systolic number that is higher than 120, which just means you have excessive pressure on your artery walls when your heart beats. Fun fact, the machine doctors use to measure blood pressure is called a sphygmomanometer. Sphygmomanometer. It's just the blood pressure cuff that you see every day in the doctor's office. Has a really complicated technical name. Now, we'll discuss two types of conceptual projects that are related to the circulatory system. This is important because conceptual projects require you to do more than just memorize facts and figures. They make you think of a question in context, so how it could affect your life or other people's lives and how you would go about finding information that is more than just a simple yes or no answer. The first example we have is, we hear that high cholesterol is bad. Develop a short presentation on cholesterol covering what is good and bad cholesterol, how to improve, aka increase or decrease both, and what nutritional suggestions can get you there, along with physical activity. Now for the second example of the type of conceptual project you might see in class. It reads, talk about CVD, what, where, why, and disseminate critical information. Now when you see this prompt, you might think, well, what is CVD? I've never even heard of it. That's no problem. Whenever you don't recognize a term, just Google it. Google will tell you that CVD stands for cardiovascular disease, aka heart disease, aka the cause of heart attack, stroke, high blood pressure, and many other heart-related problems. So in fact, you probably have heard of CVD, you just didn't realize it. Now for this project, like it says, what, where, why, disseminate critical information, you need to make a presentation explaining those topics. Okay, so now you know all the crucial parts of the circulatory system, and you've thought about how to use this knowledge in context to create a conceptual project. Or, if you're still not confident about the parts of the circulatory system, review this presentation as many times as you need. And don't forget, on all your presentations, you need a works cited. This video is no exception. Thanks for watching.